So one other thing which we'll also do that you will see is we'll record the session. So you will be able to, like, let's go back and review it also as you go through it, whatever we talked about in the class, so it helps it. We'll probably do the same thing when you're doing the activity as we go through it, so. So let's start talking about it, what we're gonna do it in the course of 10 weeks. What we're gonna do it is we're gonna start with basic understanding of the software development process and software quality assurance. Then we're gonna actually start building out the actual articles, how you will be doing it in your normal day-to-day work at the normal companies. We'll utilize that using the real life projects. And along the way, we'll give you exposure to the tools that you will be utilizing, also to do your job. There's tons of technology and terms that you will see here. There's a whole bunch of here. Don't get worried about it. As we go through it, you will start picking up all of that. Okay, so let's start talking.
Can I just add one thing? So the restroom is right here in the back, okay? So just in case if you need to use it, yeah.
All right. So let's get started. Okay, we'll start with trying to understand what is the software and the high level process to build a software. Okay.
I just want to add, if you have any question, feel free to ask. We can stop anytime because we want.
Make it interactive.
Make it interactive, okay? Anything. There is no question is bad question, okay? Just ask anything that you don't know. But if you have a question. So with that, I'll let you guys.
Yeah, for online, I don't have my video feed turned on. Because I'm doing the presentation, so if you have any questions, feel free to speak up.
You can turn it on if you want.
Yeah, another screen.
Oh, okay.
So just speak it up as you go through it, and we'll turn it on as we start having a question and answer sessions.
Okay, so I'll let you work with the students today.
Okay.
And I'm here, but I'll let you guys work through, okay? And let me know if you need anything.
Sounds good.
Alright.
All right, let's start with the software, right? I see it like some of you have exposure to software, some of you are like it's completely new to software. But think about software as nothing but a set of instructions that you give it to the computer to perform some task for you. Okay. So all of you have already some exposure to the software. You utilize phone, right? Everybody has a smartphone. So you go there, it has a software on it, right? Whether you're searching for something on the internet, or you're taking the picture or processing or editing the pictures, those are nothing but software. You mentioned, Pooja, that you work at the State Department, right? And then keep all the policies, right? All of the policies is probably stored somewhere in some sort of Microsoft Office document, whether it's a Word or PDF, right? They will have some sort of document management software to do that. All of those are nothing but a software. Okay. Anybody plays video games? Right? They are nothing but a software as you go through it. Okay. We all paid huge amount of money back to Uncle Sam. That software, it's nothing but software. Okay. So we
Whiteboard.
Yeah, whiteboard.
Yeah.
It's still in there.
Search for whiteboard, yep. Yeah, there you go.
Okay. So I want you to visualize like it's how these computer software and everything works, okay? So. Think about. Computer. It's a big box. Okay. At the bottom. You have something with the hardware. Okay, so these are the physical thing that you touch it. Whether it's a laptop, your MacBook, or whatever the software, the machines that you use it. On top of it, there is something called a system software. A lot of times you will know it as operating system. Right? So if you're using Apple computer, it will be a Mac OS, and they have different versions. If you're using it Chromebook, you'll have a Google operating system. If you're using Windows, you'll have Microsoft Windows. Like right now, it's Windows 10, 11, depending on whatever version you use. Okay. And on top of that, something known as an application software. Okay. Now, along with the hardware, always there's something called as a firmware. Okay. So let's talk about how each one of this thing works together, right? So all of you have a phone, right? Think about phone is also nothing but a computer. Okay, so everything that you touch it, when you keep things in the hand, it's a phone. Okay, now inside that there is a small set of very what's this? A machine written language code that's something known as a firmware. All it does it is essentially gives an instructions to your hardware what to do. So when you make a phone call, right? The firmware essentially takes that information and tells the hardware to send the particular signal to the tower so that it becomes a phone. Okay. The way it works is all of the system software essentially communicates through the firmware to give the instructions to the hardware. Okay. Within a hardware, you will have things like CPU or central processing unit. You will have graphics processing unit. You will also have things like your memory. So all of you use like its phone, right? So it tells you, hey, how big is the capacity, right? Somebody said, hey, it's a 128 gig capacity. It'll have like 4 gig RAM or 8 gig RAM type of things. So all of those becomes your hardware. The system OS essentially utilizes the firmware to give an instructions to the hardware. And the system software is essentially designed to work with this hardware only. So it knows internal detail, hey, this is what configuration of my hardware is, and this is how I send the information. Okay. And then application software is your software which runs on top of system software. So if you're taking it a picture, right? So you will have a camera icon. Camera is nothing but an application software that then interacts with the system software, which in turn interacts with the hardware. So when you're taking a picture, right? Application software tells the system software that, hey, capture this image. And then system software essentially sends those instructions to the hardware to open the camera lens, wrap that, whatever that moment is, and then store it as an image. And then it comes back, and then that image is then visible to you through the application software. Okay. A lot of times, this particular component, that is system software and hardware, is also known as computer platform. So you will hear a word like Solar, as you talked about, right? You're in AWS, right? AWS will also have things like its Windows image or Linux image, right? And then it'll have an operating systems running on top of that, either Linux and Windows. That's nothing but your computer platform. Okay. So you will a lot of times keep saying, hey, what is the computer environment or computer platform that you use? Somebody will say Windows, somebody will say it's, hey, we use Linux, somebody will say we use the Mac. What that means is the combination of system software and the hardware. Okay. And the way you know something is an application software is something that you can add later. Okay. The way you know something is a system software, that means without that, you can't have that computer or machine working. Okay, so that's the differentiation between the system software and operating system. This is must required for every compute platform. This is all optional things that you add on top. So if you think about it, if you are like it's on the phone, right? If you're an Apple store or if you're in Google, you will have Play Store. All that it does it is allows you to enable download all the application. So whatever you download through that will become a part of your application software. You have a question? Nana? Okay. So it's clear how everything works together at a high level. Any questions? Okay. So. So we just talked about the system software, which essentially coordinates the activities, the middle layer, which works between the hardware and your application software. Right. A lot of times it's known as computer platform, which is a combination of hardware and the operating system. And then application software is essentially something that runs on top of it that enables you to solve certain business problem or help you with needs. Okay. We already talked about it. So when you talk about the application software, things which runs on top of the operating system, there are three different categorizations you can say about the application software. Okay, the first one is a proprietary software. And this proprietary software is essentially it's owned by a company, it's developed by a company, and it's used for their own purpose. Okay. So take an example. If you're working in a banking industry, right, you go into the bank's website, right, to perform your deposits, balance check, and all of those things. Those things are built by bank. It works only within the bank environment. Okay. Another example is I know you work at AWS, but everybody purchased something online, right? Everybody has done it to some days, all of the software or all of the things that purchased from Amazon. Right. So when you go to the Amazon's website, right, the whole thing that you see it in their Amazon's website, what do you want to purchase there? Do you want to like it to watch a video and all? All of this is Amazon's proprietary software. Okay, it's built for Amazon's purpose to do the e-commerce. And it's owned by Amazon. You can't just say, it's okay, let me take that on my things and sell it as my software. You can't do it. You can't take that as is and install in your environment either. It works only in Amazon's environment. Same thing, right? So like it's when you go into the Apple, like the MacBook, there are a whole bunch of software which runs only on the MacBook. And it's owned by Apple. You can't just take it and buy it, purchase it separately. You have to purchase it only from it and runs for Apple. Okay. The second category is off-the-shelf software. Okay. So takes an example. If you're like trying to like it's buy some video game, install it on your machine. to run, whether it's in a MacBook or Windows machine. Another example is if you buy a Office 365. Right? So you're just purchasing off the shelf. You purchase the right and you install in whatever the machine you wanted, whether it's a MacBook, Windows machine. Okay, so it is kind of, doesn't need a specific environment only to run it. It'll run in multiple environments. You can purchase it off the shelf and use it as you need it. And,
Talking about the off-the-shelf software, I also thought that maybe it's like a software that is already coming to like a software that is coming to the company, but is not yet out for the market. But they're still testing it inside within the system, like before purchasing it, before taking it outside to the market.
oh, yeah, so that's the beta software. So that has nothing to do with this categories, right? So as we talk a little bit later in the class tomorrow, we'll talk about the different environments and when you do that. Right? This is, I am as an end user,
Okay.
I want to utilize this. Right, so what are the ways or categories of that? Okay. And the final one is something known as open source software. This is the software essentially is developed by community of developers. Okay, and it's available for everybody to use for free, as long as they follow certain licensing agreements. Okay, so the top one is essentially owned by a company, they use it, but it's not available for the general public to use it. It will be only for their customer or their employees only. Second one is you can purchase it, you pay certain fee, but you purchase it and use whatever way you want to use it. The third one is it's free, you can download it and use it like that. So if you look into Android operating systems, right? So if you have a Google phone or Samsung phone or any other non-Apple phone, the entire operating system is open source. You will also hear as we work into the various tools as well as the different technologies throughout the course, you will hear about things like it's a Java platform, right? It's a Java programming language. It's an open source. You don't have to pay anything to use that particular operating system. We'll talk through a whole bunch of other such examples. Okay, the condition there is you can use it as long as you have certain licenses. From the sense that you can't sell it and make a profit from it, but you can put the services on top of it and charge people. Okay. So one of the operating system I talked about, the Linux, that's an open source software. You can download it, you can make whatever changes you wanted and use it for your purpose. Okay. The difference is the first two, proprietary and off-the-shelf software, you do not have a source code. You don't know how the software is going to build or change it. Versus open source, you can go ahead and change it because you have an access to the actual original source code. Okay. Any questions before we jump into the software architecture? Okay. So this is the definition of software architecture when you look into the Wikipedia. It essentially, it's a setup structure in the relationship between those structures. Oh, it's just on the right side. So it's a setup structure. And you put together in order to build it, but it also talks about what is the characteristic of each of the component is, and what is its relationship with the other component as they work through it. Okay, so I'll give an example. If you think about building any house or building any buildings, right? They always give it first, what is the architecture of the building, right? And when you think about architecture, it talks about all of the different components in that building that puts together, right? The heating system, the electrical systems, the airflow systems, how the frame works, how the foundation works. How much is the load bearing, how you can connected various plumbing systems into that. That entire thing becomes a software architecture, right? It says how much is the height, width, what type of components, if you're like building a room, where you're gonna have an electrical points to connect to it. All of this is part of the software. If you're building a bridge, right, think about it, it tells you like it's what is the different types of bridges gonna be, right? So you can have it some suspended cable bridge, some essentially wooden bridge, some essentially, when you look into it, over the water type of bridge with the whole columns coming out, going all the way to the foundation of the water, and then right. Some could be fully concrete, some could be fully metal bridges. Let's go through it. Okay, so think around it, all of those things is built over so many years. Okay, and I'll walk through it, the example of houses, right? So where do people live? And you will see it, the similarity. So think around it. So many years ago, like maybe like thousands of years ago, right? People will live in caves, right? So they will essentially like carve it out things in the cave and stuff, right? So that's one type of architecture, right? You're not living in open, that's everything is in the cave. As the time progressed, right, the humans went started like it's making it the houses out of the wood structure, right, and the mud, right? So they will make the huts using the wood and the clay. Then as the time progresses, right, those started becoming it more solid and robust from the stones, right? So they will put together, so if you look into the old castles, right, thousands of old castles, all of them were built from the stone. They will put together the stone, use the mud and make it more durable. Then they started coming and then you will add additional fabrication like it's metal on top of it. You will start making it from concrete, right? Sometimes in between those things, they made it all wooden logs, the log houses and stuff. And then when you look at nowadays, right, you will have it, things made it out of a lot more composite material. Like whether you will say the drywall, the wood, some concrete foundations, all of them mix and match. Now, you can also see it as standalone houses. Or you will also see it's a huge apartment buildings. Which is multi-story. All of those have different architectures. But it didn't happen overnight, right? So it evolves over the period as you go through it. Same thing with the software. Okay, software has been now around for almost, I would say 90+ years. And it's been evolved over the time. Okay, so we'll talk through it, how the software is evolving, right? But you will still see it, like, and when you refer back to those houses, right? You will still see it, there are some old houses, some new architecture, right? So over the period, as the humans evolve, you will start seeing a various variety of architecture. Some more suitable for depending on the place where you're looking for. Okay. So same thing in a software world. When the original software started coming into early 1930s and 1940s, right? Everything was a one big monolithic component from an architectural point of view. Okay. There are two predominant parts when you look into the software. One is essentially the code or instructions, right, of what things needs to be done. And the second part is the data. What data are you gonna work on? Okay. In the olden days, right, when the computer just started coming in, there was no presentation, right? You just feed certain things and along with the data and then becomes a code. Okay. I tend to look a lot of history type of movies and historical things. So I don't know if you ever have watched a movie called The Name? Okay, it's a movie around the Second World War. So the backdrop on that is the German will code all of their messages using some sort of coding mechanism and send it communications. And the Allied forces were trying to figure out what message they're sending it, where they're gonna do attack, what kind of things they're gonna do. Okay, but in order to decode those messages, it was taking them forever. So there was a British engineer and scientist who built a machine called, and his name was Alan Turing. He built it what called as a Turing machine. Okay, that is the first example of the computer. What it was is there was a whole bunch of mechanical errors. There was no electronics at that time. And then they will feed the information manually, like it's whatever the coded message is. And then they will run through a whole bunch of mechanical devices and gears in order to figure out what the message is, and they will get the probability, oh, it could be this or it could be that. Okay, that's an example of monolithic application. You put the information into the machine, and then you run through those code to figure it out what it means to do. Okay. Then as the computer industry started evolving, they said, hey, you can't have everything. And then the size of that machine was probably 4 times the big of this room. Okay. But as things evolved, they started thinking about it, hey, we need to, it's a very expensive, right? And even in those days, it would be millions of dollars just to buy one computer. So they started figuring out and say, hey, we have to make a better use of this investment. Because most of the time it's sitting idle. So that evolved into what is known as a client server architecture. But they said, hey, you know what? If there are multiple people or multiple endpoints who can give the work for a computer to do it, the computer can do that and send back them a response. Therefore, now I have more utilization of computer. But as they started building that, right? Think about the complexity started getting added to the computer environment. Okay, so when I look at monolithic, there is no, it's either everything is connected together or there's nothing. Right? So I don't have to worry about any interfaces or connectivity points. But when you go into client server, you need to start thinking around, hey, this request has gone to this coming from this client. I need to make sure the response I send it back only to that client and not to other clients. Think about it, right? If you have a bank account and I have a bank account, and we both log into bank account and ask money, one person asks money to deposit, the other person asks money to withdraw, right? You don't want to send, if I'm asked for a deposit, you don't want to like it's crisscross my deposit message and send it to you, or vice versa, right? So I have to worry about it, making sure if I send a request, I'm the one who getting the response and not gone to somewhere else. So that's first complexity you need to start thinking about if I'm like testing that software, right? To make sure, is this working? Then I need to start thinking about that piece. Second piece I need to think about it is, this is now a separate component. It's no longer a one component. What happens if this connectivity goes down? What happens to my request? Or I made a request. Before I get the response, the connectivity goes down. Where do my response go? But what happens to those? I need to start worrying about testing those scenarios now. Think about what could be proper working environment. What happens when things doesn't work as expected? Then it started evolving it as the computer started becoming a little bit more accessible. And then in like early 70s, the electronics started coming out, right? So Intel spawned what used to be a RISC architecture, Sun Microsystems started forming and becoming a more affordable computing environment. So most of the companies now then started utilizing it more and more computer, and as they started utilizing, they started realizing it. There's not only the data and the code, but there are three aspects of it. So that's when they started breaking the applications into three-tier applications. So they started thinking around, I have a data, I have my business logic, and then I have my presentation. So think around it. In any company, the most important assets is the data. It's not the hardware, it's not the actual physical property, right? It's the data that they have around the customer. Right? So you work on the AWS, right? So when you think about Amazon, right? Online retailer, what is their biggest asset? It's not the software or that. It's the millions of customers that they have which purchase it, right? And all the information about their customers. Right? If you go to the bank, right? The most important thing for them is the data, right? How many customers I have it, how many accounts they have it, and how much money or assets or loans they have it for those accounts. Right? If it's credit card, right? It's not money, but it's how much loan or how much your rotating balance and those things. So that becomes the data. They know that most importantly. So they started protecting the data in a different way. Then on top of that, data is just the data, right? Unless you tell a story through that data, or you enable people to work on that data, you don't get the intrinsic value out of that data. Right? That's where your application here is, right? So if you're a bank, right, it is your ability to deposit, withdraw the money, right? Ability to perform the transactions, right? So when you are doing a credit card, it's all those transactions, right? So all of those things is applications running on top of it. But then, how are people going to access that information? How are people going to access those capabilities? It's through some sort of presentation to you. So when you log in into your bank account, right, you go through something known as a browser or through the app, which has some sort of an interface, right, which is known as the presentation view, how I'm presenting this information to the user. Okay. So they started breaking it into three different tiers, right? So you will have a terminal or a Windows or some sort of devices, which essentially it's kind of user is using it to access it. Then you will have the actual business applications or business logics. Right? The way, let's say, all of you use YouTube, right? So the way Google provides it based on your preferences, all of the what video feeds you need to see and type of things. It's nothing but their own proprietary application. If you use a Facebook, like what feed shows up in your personalized feed or Instagram, all of those things is nothing but an application. And the actual data is all the videos. Right? They have stored a whole bunch of videos, the people, your personal public videos and your news feeds and all of those things comes in. So that's how things work together. Okay. Any questions on 3-tier before we move on? Okay. Then came an internet in 90s. Okay, so mid to late 90s. And then people started thinking around and says, hey, you know what? I'm not now limited to only hundreds of users who could actually, let's say, think around the bank or think about the bookstores, right? Earlier, you were limited to actually walking to the bookstore, getting the book, right? So your number of customers, the number of concurrent transactions you will have is the only number of people who shows up in your bookstore at the book, right? Or on whatever the check-in terminals you have. Okay. So if you go to, let's say, Kroger to do grocery, right? And all you have to worry about is how many people or how many checkout counters I have. That's the max number of users. Right? So that was in this world. I don't have to worry about too many users, I only maximum. But when you started becoming an internet, now, how many checkouts can happen at the same time? not only number of terminals, but actual number of users who can log in from their home and perform the order. Right? So I have to start worrying about now. Huge amount of people performing the transaction at the same time. Okay. So, if you look about things like Black Friday. Right, things like it's today, it's like it's the NCAA Final Four tournaments and the basketball is happening there. Think about how many people will access those streams online, right? If you're watching a Super Bowl, millions of people accessing it online, right? So number of users now are in the millions. And they're probably accessing information at the same time. So you need to start thinking around and say, hey, how are we going to support it, all of those millions of users performing the transactions? So you have to then start thinking around breaking the three-tier architecture into multiple, right? So the first slice that they perform it is on the data tier side. Okay. Typically, when you store a data, let me actually, before I get into it, let me give you a view of how the information works. Okay. So now this is a very high level, that there is a detailed computer architecture stuff works in, right? But I'm going to give you a high level so that you can put things into perspective. Okay. So when you look into a computer, right, it has something known as a central processing unit. CPU. Okay. So think about it. This is the brain of computer. This is where all of the instructions goes into computer, and this is where all the computation and task happens for the computer. Okay. On that CPU, you have something known as level 1 and level 2 cache. Okay, a very small amount of memory. Okay, but that memory is integrated with the CPU. So it operates it very fast. And when I say very fast, if I look at a second point of view, it operates into 10 raised to minus 9 seconds, right? So it's a billions of instructions or billions of instructions that can store it on a given moment in a second. Okay, it's very fast, instant. Okay, on top of that, within something known as a motherboard or the actual device where the CPU is connected, they will also have something known as a random access memory. Okay. And this thing is typically about 10 times slower than the memory which is stored in the DRAM. Okay. And the way it works is your CPU always takes in instructions from your level 1 and level 2 cache. Okay. And this one is a very small memory. Okay, when you say it's small, I'm talking about 2 to 4 megabytes, right? So when you take it a 25 megapixel picture, that particular file that you take that picture is usually about 20 meg. So think about it, it cannot even store a 1 big picture. It's that small memory. But CPU takes all the instructions from it. And whenever you run out of that instructions, what it does is that DRAM goes to the RAM to get the instructions and then do that. And this RAM are typically, so this one is in the megabytes, this one is usually anywhere between 4 to 32 gigabytes. So when you go to buy a computer, right, you will ask, hey, how much memory RAM it has it, and how much is something known as a hard disk it has, right? So a lot of times you get the SSD hard disk type of thing. Okay, so that is something known as a hard disk on top of it. Okay, so everything is in memory, but then this is not on the chip, not on the motherboard, it's a separate one. So this hard disk usually gets you the access, which is about 100 times slower. Okay, but typically it's 1,000 times slower than what is in the CPU. Okay. This one, it's usually you can now get into 1 to 4 terabyte type of things. So if you, let's say if you walk in, go to Micro Center and says, I want to buy a computer, right? They'll ask it, it's okay, how much memory you need it, and how much hard disk you need it. So that's your memory, this is your hard disk. This is your CPU, and then what is the level 1, level 2 caches? Okay. Then, on top of the hard disk, obviously sometimes in the big corporations, 1 to 4 terabyte is not sufficient, right? So they will have something known as a network attached storage. Something connected to the network, but it's not with you, right? And this could be a cloud also, right? It doesn't have to be, right? So when you go into, if you're using iPhone, right, there's an iCloud. If you're using Google or Android phone, there's a Google Drive, right? There is a Microsoft OneDrive. That are nothing but the form of the network attached storage. Sometimes within a corporation like Tenet, or some of you may have it, right? You're trying to keep all of the home videos, everything connected in a central place, and then you want to watch it from any of the TVs. Right? That is nothing but a network attached to it, that you're connecting to your home network and you accessing it from everywhere. Then on top of that, something known as offline storage. So sometimes you want to keep it last 10 years history, but you're not going to access it regularly. So you want to put it up on there, right? So the NAS, these are typically in the stroke excess of millisecond. This usually gets into sub-seconds or seconds type of things. Offline, sometimes it even takes more than seconds. Okay. So the question comes in is, as you go through it from a CPU further away, things become slower and slower. So why even do that, right? Why not move everything? The reason is the cost, right? So when you look into the L1, L2 cache, right? Roughly, it is costs you about $100 per megabyte. Okay. And as you go into it, this thing will probably cost you about $50 per gig. Okay. This hard disk, you get a 1 terabyte hard disk nowadays for like $50-$60. Right? So this goes into terabyte. Terabyte is nothing but 1,000 times the gigabyte. Right? So this is 1,000 times cheaper, right? So if I were to do it in gigabyte, right, it's probably $0.05. This, then this, the more the further you go, the cheaper it gets it. Okay, so there becomes a cost factor, right? So a lot of times when the corporations are building the architecture, they have to balance between the speed and the cost. Okay, so this one, it's a smaller, right? So think around it. Hey, if I'm trying to like store it, millions of customer data, there's no way I can store here, right? Because otherwise it's very, very expensive for a company to operate. And that is also a physical limitation, right? You can store so many chips onto a given microprocessor device. Versus if I go in here, I can easily accommodate millions of customers, but my speed is going to be very slow. Okay, so to deal with that, that's where this architecture comes in. Okay, so the SQL database typically are on the NAS drives or on top of your hard disk, right? Which is usually about 1 to 2 millisecond type of fastest response. Then they take that into something known as in-memory data access layer. Okay, so this is on your memory now, which is probably 100 to 1,000 times faster than this. The notion there is, even though I have 1 million customers, not all million are performing transactions at the same time. I have only some subset of it. So they manage the communication back and forth in this one and says, anybody who is actively performing a transactions, keep them in the data access layer. Anybody who is not performing the transactions, move their data into it. And bring it only when it's needed. Once I'm done with the transactions, bring it back. So if you notice that, if you try to log in into any of the online systems, the first time you log in, it takes a little bit more time than any subsequent operations that you perform. Right? So if I'm logging into my online banking account, right? The first time I provide my user ID and password, it's going to take a little bit more time. If you notice a fraction second or two more than every subsequent transactions that you perform. The reason is, when you perform a login, it says, oh, you're going to be active user. That is a probability that you perform a transaction. So they try to take all of my information from the database and bring it into data access layer. Okay, and from that point onwards, I'm interacting not with the database, interacting with the data access layer. And then it will, once I'm done with the transaction, it will push it to the SQL data. It'll keep this to synchronize. Okay, so what it does is, it now allows me to serve millions of customers at the same time with a reasonably high speed, but still maintain all of the information. Okay, so if I looked into this tier, they broke it down into two now. One is in memory, another one is in the more storage devices. Okay, my application tier is now my business layer, right? That's still the same. But then the presentation tier, which was a one big thing, now they break it down into two. Something known as a presentation tier, and the other one is known as a user interface. Okay. So presentation layer is essentially, think around it. I could access my bank information from my phone or from my computer. But when I do the things from phone, my user interface is going to be different because it's a very small screen. It's not going to show me everything. It's going to be show only certain things. But same thing, if I'm accessing on my computer, I have a much bigger screen. I will see a lot more information. Right? But when I look into, hey, what is my balance of my account? The information is still the same. It's only how I see it is a little bit different. So it still pulls the same business logic, it's just get this guy's balance, but how the balance is displayed is a little bit different. That's what the multi-tier, right? So your presentation tier and the data tier are now broken into two pieces. Okay. Now, as the internet started evolving, companies started thinking around, hey, I'm not the only one. I'm going to like to provide services across multiple things in order to build a solution. So again, let's go back to the Amazon's example. So when you're trying to do an online purchase, at some point you have to perform a payment transaction. So Amazon, when you go to it, right, your credit card may be from a different bank, my credit card may be from a different bank, Pooja, your credit card may be from a different bank, right? So Amazon doesn't have all of the payment capability. They have to work with somebody else to say, hey, here is the card information. Can you tell me if this particular user is allowed to perform this transaction? So when you try to do it, first thing does it is it checks it whether you have a valid credit card. Then it says, even if you have a valid credit card, are you allowed to borrow that much money in order to perform transactions? Right. Let's say I have only like $500 credit card limit. And I try to go to Amazon to buy $1,000 TV. Right? It's gonna reject it and it's gonna say, hey, even though your credit card is valid, you don't have that much limit in order to purchase that. Right? But that work doesn't come from Amazon, right? It needs to be from your bank, whatever that you have it. Right? So if I'm performing an Amazon purchase, now Amazon not only has to provide the services that they provided, the item that they need to purchase, but they also need to work with my bank to get the information in real time, right? And the bank will provide the service to say, give me the credit card and I'll tell you whether this is valid credit card and if they are allowed to make this purchase. Okay. Then, once you make a purchase, Amazon has to ship the item to you, right? They may use UPS, they may use FedEx, or they may use their own Amazon's warehouse distribution system, right, to ship the item to you. But when you go look at it, right, you are able to track it, hey, where is my order? Is it shipped? Is it like it's in transit? When it's gonna be delivered, right? So all of that information, Amazon has to interact with whoever is providing shipping. Right? So when you think around it, right, now companies are providing a solution that involves the services from multiple businesses. Right, so that in order to facilitate, they have to build an architecture, right? Your application has to provide those capabilities. That is done through service-oriented architecture. Okay, so in this, think around, you still have that presentation layer. Right, you go log into the Amazon.com. Everything looks still the same, Amazon side, right? It doesn't tell you, hey, I'm going to take you here or go to this bank, go to this shipping in order to get. They still give you everything through the same interface. Okay, behind it, they have something called an orchestration. So my orchestration, if I'm purchasing a product, it's going to be a different process. Then I'm checking the status on my purchase. Right? Or I'm checking my profile to do something. All of those things is going to be different now. So the way, think for a moment, I want to perform a purchase on Amazon. Right? What is the first thing you do? You look into it, show me all the product that is available for me to purchase. Right? So you will have a service layer which says all the products. So that when this orchestration engine says, show me the products, it will do that. Now you may want to narrow it down and say, you know what? I don't want to see everything. I just want to see what are the video games available. I may be even more specific and says, show me all the Xbox video games. Right? So that service, then it just shows you, this is my product service, it's going to narrow it down. Behind the scene, it may interact with a whole bunch of other systems to say, hey, show me all the Xbox products. Then the next step is, I'm going to look into the detail. And if I like the detail, I'm going to add that to the cart. Right? So in my orchestration, add to the cart. And then there will be search more items. Or the option will be is checkout. Right? So that's orchestration. See how it flows in? I'm looking for a product. I like the product, so I'm looking the detail. I add the product to my cart. I continue the shop, or I can check out. When I check out, it goes to the payment system, right? So you may have a payment service. That payment service may connect it to a completely different company service behind that. And then they may have their own systems, which has keeping it all of their data. But that payment service then comes here. Let's say I made a successful payment. Then it's going to give me an option, how you want this thing to be shipped. Do you want to download it? Then it's a different place. Or I said, hey, I want a physical copy, send me that. So they said, okay, do you want it a 1 day, overnight, multiple days? Right? Based on that, they will say, oh, you want it overnight, so I have to use one of this provider, which provides the ability to do overnight. Then it enables me to track it. Okay, so you have a presentation, you have services that may be from your company or maybe from different company, but you're just kind of orchestrating for that. And all along, right, you need to worry about how you're gonna communicate back and forth between the different companies over the internet. You need to make sure you're managing the security as well. You don't want your credit card to be sent it out and open, but here's my credit card number, here is my passcode, here is my expiration date, here is the amount and all those things, right? It gets encrypted. So all of that comes from that framework, which enables you to go span across all the layers. Yes,
Would PayPal be an example of like a?
so PayPal is an example of the payment service,
Okay.
right? But when you think about eBay,
Mhm,
eBay is that, and one of the payment you can do it through PayPal.
mhm.
Any questions around service oriented? Good? This are like, it's roughly 2000, early 2000 is when this started getting because of the internet, right? The company started offering, and now you had started having a businesses which then orchestrates multiple companies to provide you a single service. Then came around 2007. Right? And Apple released iPhone. And then right on that hill, Google released the Android phones. That now enable people not to be tied to their home or their work location. They could be mobile on their phone or on their iPads, and then can do the same transactions. Okay. When I look at here, right, my complexity, I have to worry about is when I'm testing it, is my service with the other company up or no? Right? If they're up, I'm already connected, right? And then I'll be able to do it. So the complexity increases from the multi-tier or one-tier because now I'm going outside the domain of my own company's network, going over an internet to do the things. This thing adds another layer. Now I have to worry about, am I even connected or? Right, because you could be driving it in Montana and you may not have cell tower receptions. What happens to your transactions you're performing at that time? So I would always worry about whether I'm connected or not connected. And whenever I'm connected, I don't want everything. I just want to give me from the last time I connected. Let's say you're checking your emails or text messages. Right? You can work offline, typing in all your emails or text messages. And whenever you get connected to the tower, it says, yes, I have a connectivity. Now I can send all the messages. But it doesn't send every message, right? It sends it the messages only from the last time you connected to the present moment. Same thing with the email, right? So now you have everything that is kind of stored on your mobile device. And then whenever the network comes in, that mobile device syncs with whatever the server that you're connected. For the email, you may be separate. For your banking transaction, you may be separate. For your text messages, you may be connected to the separate server. Okay, so each one of this side of the house, they may still have the same service-oriented architecture implementation like this. Right? But then you will have some sort of replication on this side where you have some local storage. So all the email, right? Because even if you're not connected, everything that you've downloaded, you can still see it and view it. Right? Whether it's a video or whether it's email or whether a text message. And then whenever you connect it, it just securely connects and says, give me from the last connection I have it. And here is when I was connected last time. Right? And then this sync essentially pushes you the data from the last time that you were connected. Okay. So that's a mobile application. So that's much more common nowadays that you see. Okay. Now, we talked through like 6 different architectures, right? You will still see it, the different forms of those architecture in different systems today. majority of times, when you're gonna go look into the workforce, you're gonna interact only either with the multi-tier or service-oriented architecture or mobile architecture, depending on the type of application that you're working on. The only exception is if you're working on some of the manufacturing type of things, right? So for example, if you're working on things that works on automobile factories. Okay. Those things is not necessarily going to be multi-tier architecture, there may be still the client server type of architecture. Because everything is contained within that. Or if you're like it's working through a proprietary, let's say you're driving your autonomous vehicle. Right, so you're driving Tesla or driving any of the Chevy Bolt or some of the newer ones. You may still have some proprietary and some multi-tier architecture. So just be mindful that you may have a different type of architecture depending on the workplace and depending on the application that you're. Okay. Any questions on this one? Okay. So we talked about what the software is, we talked about the high level architecture. Now let's talk about how you build the software. What is the development process? Okay. So think of, let's say if I want to buy a house. Okay. From that point till I own a house and I want to like sell a house, that entire thing is nothing but a lifestyle. So let's talk through it, how you would visualize that, right? So if you want to buy a house, right, what is the first decision you're going to make? The first decision is, am I ready to buy a house? Is there a need for me to buy a house? Right, let's say if I'm moving it from one town to another town. And I need to like find a accommodation, right? That drives my first need that, hey, I need some sort of living accommodation, right? And then I can make a decision, hey, do I want to rent it or do I want to buy it? Okay. That's a decision and it's going to be based on how much money I have. Do I have money to buy the house? If I have it, then I potentially look at it. Other factor says, okay, does it make sense, financial sense to buy a house? Or it makes it more sense to rent a house, right? So I'll make some sort of that decision, right? So that's my planning. What do I want to do? Right? Let's say once I decide to buy a house, right? The next thing is I'm going to do it is what type of house to buy. I'm going to buy a standalone house, or I'm going to be buying an apartment, which is a multi-story. Do I want what kind of backyard I want? How big the house I want, right? So I'm going to start putting together what is my requirement to buy a house, right? So I go make a decision and then I go into my analysis, is what I wanted. Once I decide, hey, I want it, let's say 4-bedroom house, I want a backyard, I want a nice lawn for me to like just relax it and that. So that then becomes what design you can use. Right, so I will hire an architecture to say, can you design a house for me? Here are my requirements. So the architecture will create a blueprint for the house. Right, they will go through a whole bunch of approval from the county wherever on the house to say, is that county allows those kind of house building or not. Then, once I decided, and once I get the blueprint and architecture laid out of what house I want to build it, I'll hire a contractor to build the house, right? So I take it the design and I construct the house from the design. As the house is built, right? There's gonna be inspection, people are gonna check it, is it getting built according to the right specification or not, right? And once the contractor builds the house, they're gonna just say, hey, mister, your house is ready. Can you just walk through it? I'll show you that I've built a house according to the design and the blueprint that you give. Right, so you will do something known as an inspection, right? of the house and make sure everything is working. As part of it says, hey, let me make sure electrical systems are working, let me make sure my water system is working, my heating system is working, my cooling system is working, my drainage system is working. So I'll test all of those things and make sure everything is working. At that point, I'll be ready to move in the house, right? I'll start utilizing it. And along the way, I may decide, hey, I need to extend it, I want to build my patio, I want to build my deck. I want to build additional capabilities in the house, right? I want to furnish my media room. All those things you added, same, you'll go through the same, right? What do I want in the media room, like requirements, going through it, all of those process. So that becomes your entire life cycle of the house, right? Same thing for a software, right? So how you go about thinking about to building a software, that entire thing is known as software development lifecycle. No, don't have. So think about it, the stages, right? So SDLC also follows the same stages, right? So SDLC is a short form software development lifecycle. Okay. First thing you're gonna decide, do you even need to build a software? Right, that's your planning phase. Do you even have a justification to financially make sense that it is worth for you to build a software? You build a software, but only 1 or 2 people are gonna use it and you're not gonna get financial benefit for the cost that you implemented. You're not gonna make that cost, right? Companies are not building software to build a software, they're building a software so that they can make a profit. Right? So there will be some sort of planning that people are gonna go through it and say, does it make sense to build this? And what kind of software do you want to build? Once you make that decision, you're gonna look into it, then analysis. Well, what should be the capabilities of those softwares? What is my requirements? Then the next phase comes in is, now that I know my requirements, I'm gonna build an architecture. But there's no point in building a mobile architecture if nobody's ever gonna access it from their phone or from their remote place, right? So depending on what you're gonna build it, and depending on what your requirements, you're gonna pick one of those 6 architecture and says, this is how I'm gonna build this one. Once you pick the architecture, you're gonna start implementation. It says, okay, let me write the code to build a business logic, let me write the code so that I can access and save the data appropriately. I can present that information in the right presentation. Once you build all of that, along the way, you're gonna test it, and you're gonna test it afterward also before, this is where you were talking about solar audio, right? They're building it, while they're building it, they may have some beta tester. But once they're ready to sell it out, then they will have user testing and then they will release. Right? And once you release it, it becomes an acceptance. Now people are using my software. Right? Along the way, they might find a bug or they may say, hey, can you add this capability also? So that becomes your maintenance. And then once you are done, once they have new additional requirement or capabilities, you start back into the cycle. And it's a continuous cycle. Okay. Any questions? Is it good? Do you understand how the development is going to happen? All right. So let's take about 5-minute break. It's like it's almost an hour and a half since we started. It's 10:23. So let's pause for 5 minutes. Stretch yourself. Need to use the restroom. Go to use the restroom, and then we'll start. After the break, we'll start talking about how are people going to go build the software? What is the development of it? Okay? Let's take a 5-minute break. So we talked about the software development lifecycle. Now, that's overall lifecycle, but the what? There's a question? So as you go through it, everybody will build its software a little bit differently, right? So that's what called the development methodology. So even when you talk about house, right? So if you go from a one builder to another builder, you give them the same design. They may take a little bit different approach to build a house. So there are three common development methodology that the software companies use it. One is known as a agile methodology, and there are a little bit variations of it. The second one is called as a rational unified process or a RUP process. And the third one is known as a waterfall process. So let's take a look at each one of them. Okay, let's start with the agile development methodology. Okay, so, and I'll try to like it's give an example. Okay, as all of you like it's familiar with the taxes, right? You pay federal taxes, you pay state taxes, you pay the local taxes. So let's take an example. I want to build a software that enables people to file their taxes. Okay, so I'm trying to do that. So there are two ways I can do it, right? I can say, hey, you know what, I'm gonna build the whole software, and then I'm gonna try to sell it. Right? Now, as all of you know, the tax codes are very complicated, right? And then there's different codes for different states. Even within the federal, right? Depending on what you file it, whether you file it individual, you file it joint, you file it itemized, you file it standard. There are various combinations of it. So it takes it, if you look at it, right, it's like almost like 5,000 page federal tax code. And then every state have that probably another couple of thousand pages of that. It's a lot of requirements, right? To implement it takes a lot of time. Typically takes like 4 to 5 years to implement if you're building it from scratch. Right? So you have two choices, right? Either you wait for 4 years, build the whole thing, and then try to sell the customer, right? So that means for 4 years, you need to incur the expenses of all the developers paying all their salaries and building the software without getting any revenue. Right? Or the option you can say, you know what? It's very complicated, but I'm not gonna worry about that. I'm gonna just build only to a small segment which says that only people who file standard tax and only federal thing. Right? It's a small enough, I can quickly build, let's say within a month or two, that piece, and I can start selling the people. Even though it's not supporting all 300 million customers who needs to file taxes. But it does it only like it's, let's say for 2 million customers who does it standard file. I can start selling, right? I can start making your money, and that money then I can invest it to slowly expand my software. Okay, so think of that mindset. If I'm taking it a big problem and says, I'm not going to try to solve the whole thing, I'm going to take a small piece, I'm going to build it on top of it. That's essentially agile, right? Because I'm kind of changing it as I'm going through it. So that if you build it that way, that's an agile methodology. In this one, you start with a vision, right? Hey, I want to build a tax software. That's my vision. My first iteration will be just build it only for standard. Then the second iteration, I'm going to make it itemized. Still federal tax, no other thing. Then the third iteration I can do it is, hey, I'm going to start putting it for one state. Fourth iteration, I'm going to add another state. And I will slowly improve. The advantage here is you're performing the whole software development lifecycle within that small increment. But at the end of that increment, you're actually putting the product out for the consumer to start using. So you're selling it, you're making your money and that. And then the next iteration, you follow the same thing and goes on top. So visualize it, right? So there's one iteration, I'm building the whole thing, right? I'm starting it from my planning phases, requirements, I'm doing design, I'm doing implementation, I'm testing it, and I'm kind of deploying it. Then I take it. So typically this iterations are 2 to 4 week iterations. Okay, in a case of agile. So that's one methodology. Any questions on it? As we go through, we'll go into a lot more detail, but that's the high level mindset of it. Good with,
Good.
understand?
Yeah.
Okay. The second approach people can do it is a rough development. In this case, you're building it into phases, but you're not deploying it. You're not selling, right? You're just building it into small phases, but you're testing it out as you're building it into small phases, right? So you may have things called, hey, I'm gonna build it only the federal one first. Then I'm gonna test it out what it is. Typically, this rough development methodology, use it for big, large scale projects. Okay, I'll give an example. Okay. If you're familiar, right, NASA is trying to put humans back into the moon and Mars. Right? It's a big project. It all requires different software in order for it to build, right? So think about, my project is not gonna get done if I'm a NASA till I put the humans on Mars. Right, that's my project. But I can't just start it from that, right? So I need to start incrementally. I need to start building small system, test it out. Right? The first system I did is, can I have a rocket that essentially takes the people out from Earth's orbit, put into the space? Right? Then I need to worry about, can they go it incrementally from low Earth orbit to moon? And then from moon to Mars, right? So there are multiple phases. But I can't just deploy, right? I need to make sure my rocket engine works first on the ground before I can like lift it off. Right? So that means I need to build a software which is control the rocket burns, making sure everything works. Then the next step, I need to build it or prototype it is that rocket essentially can take it people into low Earth orbit and can bring it back people to the Earth from there. Third one is, can they navigate it to go to the moon? Right, because I have a GPS back here, but when I go into the space, it's all black, right? It's a dark matter. I need to make sure I have some sort of mechanism to build it so that I can take a navigation to go towards the moon orbit and not go into the other opposite direction, right? So they have something known as 4 different phases called inceptions, elaboration, constructions, and then the transition or deployment. Okay. In the inception phase, that's where you collect together all of the requirements and says, what exactly I want to build it. Okay. I may do some sort of analysis and say, does it make sense or not? Then I'll have elaboration. Essentially, I take that mindset, I'm going to essentially do pilot or test things, right? So you look into NASA, right? NASA is taking the new rockets and then essentially testing them on the ground and says, does it fire? Does it fire as a unison? Does it give that much thrust to lift it off from the Earth? So all of those prototyping is an elaboration phase. So you will see it in the prototyping, there is a lot more analysis and design, more requirements. Okay, in the inception phase, you're focused more on modeling, getting it requirements, putting it together. What do I need it? Then in the construction phase, that's where you're going to do a lot more building, implementation, and test. Okay. And then eventually, once you're done with all of that, then you're going to do a transition or operation. In this case, your solution is not complete till you actually go into the transition. Okay. So let's take the example of the tech software again, right? In the inception phase, you said, hey, I want to build it. Let me collect all of the state's requirements. Then you're going to prototype it and say, what it will look like when I build it, all of this thing. I may do multiple elaboration prototyping. Hey, do you want like this kind of view, or do I want it to present this way? Should I do the state first and then local, or do I do it federal and local and state? What if somebody changes federal? How does that will impact the state, right? I have to do all those scenario modeling. Then I'll do it in elaboration. Then I will start building the actual software. And then eventually I will ship that software. Okay. compared to here. Where I was incrementally building it and making the money. Here, I have to wait till everything is built before I sell it. Yes,
So is there like such thing as one methodology is better than the other? Because I've heard like countless debates between agile and waterfall methodology.
and hold on just for 5 more minutes for that question.
Okay.
We'll talk through it. Right, I wanna make sure you understand all three, and then we'll go and say why one or the other.
Okay.
Now. The difference here is as I go along, right? If it's gonna take me 3 years to build it, remember the tax. Changes every year, right? Because the Congress passes different laws, the state passes different laws, you get different credits every year. Right, so along the way, I have to constantly, that's why you see it requirements constantly changing. Along the way as I'm building,
Mhm.
okay? So that's where the other aspect. The third development methodology is called a waterfall methodology. Okay? In this approach, essentially you just say, hey, I need to know everything up front before I can build it. Right, I need to know all the requirements before I can design. I need to finish my design before I can actually start coding. I need to finish all of my coding before I can test it. And I need to finish all of the testing before I can actually deploy. Along the way, if you say, hey, I'm kind of working on my design. It says, oh, by the way, can you do this also by changing another requirements? And then go that. Think around, if I'm building a house, right? You start with says, hey, what kind of house I want? Well, I want a 3-bedroom house, a standalone house, right? They will start putting the blueprint. Blueprint is done, and it says, you know what, I changed my mind, I want like it's now 2-story and I want 4 bedrooms. What's gonna happen? And he says, hang on. I need to redesign everything. I need to scrap, whatever I did, I need to throw it away, and I need to rebuild it. If you're like, it's kind of building a house, like, let's say you finish design and everything, it says, oh, instead of 2nd floor master, I want the 1st floor master. You're halfway through construction, what is gonna happen? It says, I need to destroy everything that we built it, and we need to start it from scratch. We need to redesign it, then we need to rebuild it. Right, so every time you do something, and if you change it, you're going back all the way to the top. And then restart it. Think around how the water flows into the waterfall, right? Every time you put it at the top, it has to fall all the way down that. So if you do it that way, hey, I want all the requirement up front, and then I can design what the software needs to be. And then, oh, if you change it after I finish my design and I'm in the middle of code and you change it, I have to go back and redesign it. I need to make sure I understand all of your requirements. That means I'm gonna go back and then I'm gonna restart from where it is. Okay, so I'm not gonna gain any value till I actually get deployed. And every time you change your mind, you're gonna restart it and my clock restarts it. That's waterfall. Versus here, says you can potentially change it. I don't have to do everything from scratch. I may just add a few things. I may have to change certain things. Certain pieces may have to rework, but I can still continue to do that. Right? So I'm not restarting. I'm still changing my timeline, but I'm not completely starting from scratch. Versus this one, I'm completely starting from scratch. Okay. Versus this one, I'm incrementally delivering. Now you ask the question of which one is better? It depends what is it.
Okay.
Traditionally, I would say most of the companies in the software development world started here. I'll give an example since I work in the banking industry. Right? Earlier, the banks will decide what products they will give it to the customers. Take like 3-4 years to build those capabilities and then roll it out to the customer. Now, if you look into it, customer tell what they want the bank provide that capability. And if you don't provide it, they will go to somebody else. Okay. Take an example. Earlier, the banks will say, oh, you have only checking and deposit savings, those two accounts, that's it, nothing else. Yeah, maybe I'll give you a money market account. Nowadays, what is most of the college going kids? You go to college, right? What do you use? Venmo,
Mhm,
right?
mhm,
I have $2. Probably they've gone to the bank only once or two times in their life. They do all of their banking online.
yeah,
And if, as a bank, if you do not support my need to do the banking online, I'll go somewhere else to provide that. But I'm telling you what I want. You're not telling me what products you will sell. Okay, if you're doing that way. And if you're trying to use a waterfall, you cannot sustain, right?
mhm,
Because your customer in the market is changing constantly. If you go this approach, you will always be running behind, catching it up. Versus if you do it, this one, right? It says, oh, you want online banking? Sure, I'll give you the ability just to send it to only my customers, whoever is your bank customer. That's the first iteration. Second iteration, I'll give you the ability to send it to the other friends who are not customer of our bank.
mhm,
Third iteration, I'll give you now the ability to move the money in between your accounts. So you see how incrementally does, as the customer changes the need, then this is more adaptive. If I'm building it, a space shuttle system to go to the moon,
mhm,
incremental, agile is not gonna help me, right?
mhm,
Because I can't just test it and say, oh, let me just send you to the Mars. Oh, I forgot to give you the water and the food and the life support system. I'll give you the next iteration. That doesn't work.
So,
You have to build it this way. So depending on what project you're trying to do it,
mhm,
what it is, most of the companies that you're gonna end up working nowadays, because of the way the customers' demands are constantly changing and the markets are evolving, you're gonna see this.
has there been a situation where the project, like they chose a wrong methodology for the project?
So typically, the methodologies are picked not at the project level, at the company level,
Oh, okay.
right? So once company starts doing it, they will start shifting that. I'll tell you, very few companies does very effectively this.
Mhm,
Right, they do with some combination of, hey, I'm trying to do some incremental work, but my deliverable to the customers is always more time-based or waterfall time. So you will see it, a combination of it, but a lot of companies have started getting into this mindset to do it. You may not release the product to the end customers,
mhm,
but you're incrementally adding the feature and testing it on that,
okay,
so that at any given point of it, you can sell it.
okay.
Think about it, right? That is another advantage, and that's where you need to think it from a business point of view.
Mhm,
If you spend money for 3 years to build a tech software. And then you figure it out at the end of the third year that, hey, this is not working, this project is not gonna work, it's so much overhead and it's gonna cost me more. At that point. You have invested money for 3 years without getting any,
mhm,
right? And you cancel a project at that time, it's a huge loss.
yeah,
Where it says, you go in an agile, you release it something for first year and the market changed, or the customer didn't like your product,
mhm,
and you decide to stop the project. 3 years versus a 1 month. Right? You fail faster,
mhm,
right? It didn't take 3 years to fail it or decided that, yeah, I'm gonna do it, you did it within a month,
mhm,
your cost is a lot lower.
yeah,
The other aspects, if your customer like it, but they don't like certain feature. All you do is stop doing work on that feature, you lost only a month,
mm,
you still do it.
okay,
Right. So. The more smaller the company, more the nimble are. The more easier for them to do the agile. That's why you started seeing a lot of startup companies
mhm,
will exclusively using agile because of the reason, the financial and the business agility thing. Okay, any questions on it?
mhm.
Now, when you think around the quality. Right? Think around building a house. Okay. Do you wait till entire house is built before you call the inspector to say, hey, is my electrical system working? Is my plumbing system is working? You don't, right? You do the inspection along the way. You do even inspections. Once you create the blueprint, you have to run it by the county to make sure it is in compliance with the county codes and everything. Right? So when you're building a house, you incrementally test it, things along the way. Your quality is built into it, right? You can't just say, hey, you know what? I'm gonna run the wiring and we'll put all of the drywall and then we'll test if the wiring is working or not. Because if it doesn't, you have to rip all the drywall, you have to rewire everything. Right? So you always think about building the quality in the product as you go along. You don't wait until the product is built to see, does it have a quality or not. Same thing with the software world. You build the quality along it. As soon as you get the requirements to build the software, you review it, it says, does it make sense? Right? They put the design. Is this design gonna help me to accomplish the requirements that I'm looking for? Is it precise enough? Before even you write the code. Once you write the code, then you test it, does it meet the criteria? Right? So your quality needs to be part of the software and not an afterthought. Because if you do an afterthought, the problem is already into the problem. And you have to worry about fixing it and rebuilding the problem. It's gonna be more expensive. And it's gonna be poor quality, right? Think about it, you do patch on, patch on, patch on, is it gonna be sound quality product? Right, it doesn't matter whether it's a house, car, software, it doesn't matter what it is. It has to be part of that, that's why you would see it, a lot of times people talk about, hey, why do you call it quality assurance and not the testing? To me, testing is a small piece of the work that as a quality assurance people do it. Any questions before we get into how we're gonna go about building something? Okay. So let's talk about the software problem. So everything starts with business problem, right? You're not gonna build a software just for having fun. Right, you're gonna build it because it's gonna help you to address some business problems. Okay, so in this particular section, we'll start talking about how the project gets started. Right, in what it means. So when you look into broader category, right, any business, you can say it's a business essentially gets into, whenever you're trying to build it, anything falls into one of the 5 categories. Okay. Either you're trying to do a process improvement, you're gonna try to do a productivity improvement, cycle time improvement, or you're trying to reduce overall cost, or you get into the new markets. Okay, let's take an example. Okay. Let's say I'm a small business. I'm a bookstore. So I have 3 bookstores for 3 locations within a city. And I have a warehouse. Okay. So that's a small business that I'm running it. Okay. And I need to essentially get better at whatever I do with bookstore. Okay. Let's take first a simple example. I want to answer my customer's question, do I have this book or not? As simple as that, right? So here's the current scenario, right? I have books piled all up in my bookstore. All 3 bookstores and same thing in a warehouse, right? And I want to answer a simple customer's question. Do I have this book or not? Okay, I don't have, forget about any software, right? I just want to answer this simple question. Let's say I don't have my books organized or sorted into any order, right? Everything is in piled up. So a customer comes in and tells me, do you have this book or not? An employee at the bookstore says, hang on, let me look through all the books to see if I have the book or not. Okay, so they go through every book that I have in the bookstore to say if that book is present or not. Let's say, to keep it simple, it takes about like 8 hours for me to do it. It takes a whole day, right? 8 hours a working day. Takes me a whole day to look through the entire stockpile of the book I have. At the end of that, I said, you know what, I don't have that book, but we have another store. If you go there, they can look for that book to see if they have this book for you. Okay, so the customer goes to the second book store that I have it, repeats that process, takes another 8 hours and says, oh, I don't have it. We have third bookstore, can you go there and see if they have it? Takes another 8 hours. So no, we have a warehouse where we keep it, all the other books also. To go there, right? So customer goes through all 3 bookstores in a warehouse just to answer a question whether I have that book or not. Takes 32 hours. Okay, so that's my problem. Okay, now I say, that's not good, right? Takes a 32 hours to find a simple answer whether I have a book or not. It's a lot of things. So I said, okay, I need to change. Now my focus is a process improvement. Let's say if I want to say, okay, I want to improve my search in the book process. I want to make it more easier. Right? So things was all sequential, right?
Mhm.
What if I just said, okay, I take instead of a pile of book, I organize them into a specific order. And when somebody asks a question, all I have to do is scan through it, physically go in, and let's say I'm able to now answer that quickly in 2 hours, right? So I improve the process. They don't have to go through every book,
Mhm.
right? They go through only certain sequence, and if as soon as they reach an alphabetical order,
Mhm.
and then it's not there for that particular alphabet,
Mhm.
it's not gonna be there, right? So I improve the process. They don't have to go through the whole book.
Mhm.
And then now I can just go repeat the same process across 4. It's gonna be faster. And it will be easier, right? Both on the customer and employee.
Mhm.
No software, right? All I just did is resorted it, the book the way I would. So if my focus was to improve the process of finding the book, that's what it is. Now, I can take another example on the same one. It says, hey, you know what? I want to make your things better, but not because I want the process to be easier, but I want it to productive, right? So if somebody asks a question, do I have this book or not? And if it's taking an employee 8 hours, all they can do is support one customer in a day. What if I organize my books with the mind that an employee should be able to serve more than one customer? Let's say my goal is to support 4 customers in a day. That means I need to have the process down to 2 hours so that it doesn't take more than 2 hours for them to search a book to give them employment. I can still do the same solution, right? I can organize it, but my motivation was improving the productivity. I want my employee to be more productive rather than just the process to be about. If my focus is that, then I'm looking at from need for productivity. The third factor could be is, hey, look, without sorting it, it took us 32 hours to find an answer, yes or no, whether I have a book or not, right? So it took me 32 hours to complete the cycle to answer that question. And if I want to improve that, instead of 32 hours, I want to do it, let's say, in 2 hours. That's my goal, that's my cycle time improvement. And I could do multiple, right? I could just say, hey, as soon as somebody comes in and says whether you have this book or not, I can organize into alphabetical order. At the same time, I can just say, instead of them going sequentially across all 4 stores, what if, like, as soon as it comes in, I can just say, hey, do you have this in your store, this store, this store, this store? I can have 4 employees go work in the federal to find that book, and whoever finds first finishes that cycle. So now instead of 32 hours, it's going to take 2 hours. Of course, it's going to take me 4 employees at the same time working. But that now improves my cycle time from 32 hours to 2 hours. with the hope that if there is a book, customer will purchase it. So I close the transactions faster than 32 hours. That's my cycle time. Another way to look at the problem is, hey, it's costing me so much to just find the book. Right? 32 hours, let's say simple $10 an hour, I'm paying an employee, it takes me $322 to figure it out whether I have a book or not. And I want to reduce that cost, let's say $50, want to finance it within 5 hours. I can still order them in alphabetically, still do a concurrent call. And then reduce that cost as long as I can finish the answer within 5 hours. Okay, so my motivation at that point was to reduce the cost. Why it's costing us so much to find a book. Okay. Another aspect could be is I'm making my customers to walk into my store in order to even ask the question, do you have this book on? Okay. What if I make them, they don't have to come to the store, they can pick up the phone, call it. And ask the question, do you have this book or not? So if that is the case, now I'm increasing the people who can actually ask me for a book from a small group that people who can walk into my store to anybody across who can make a phone call. So my market is now increased from a local city to a big one. And if that is my goal, that's a market improvement. Right. So do you see it based on what my motivation as a business is? I'm gonna make a decision whether I want a software or I want to make it different. So, okay. What you will find it is when you go into the real world, based on whatever the actions the company takes it to build the software, right? It may influence multiple of these factors, but there is always one primary, which is for the company that's driving it. All the other one could be additional benefit. But there's only one primary reason why they would go for it. Okay. Now, actually, let's take a look at it. Okay, so. What's that? Okay. We're going to see it. So in your folder, if you can look at it, if we can borrow this folder. Okay, so the way your folder is organized is, and that's how all the online stuff is also organized. So you have first tab, which is all the slides that we're talking about. The second tab is essentially the exercises. Okay. The third tab is some of the project documents that we will work through it today, and I'll tell you what you needed before we leave the day. And then fourth tab is some additional documents on that testing content. Okay, so if you go flip it to the second tab, okay, you will see a exercise 1 like this. Okay, in this one, and about, for online, did you get an email from Herschel about the project documents and location? You still there?
Yes,
Okay. Did Herschel send you a project documentation links?
yes,
Okay, so did you find the project file document? Where there's an exercise one?
yeah.
Okay, so this is what I want all of you to do. Let me hide this controls. Okay. So. You have a business problem. What I want you to do is spend 5 minutes reading through that business problem. Okay, and then think around it. What is the primary business issue it's trying to solve it, right? So there are 5 business problems that we talked about. If you read that problem statement, which is the exercise 1, look at it and analysis in that. What is they asking? Are they asking it for the cycle time improvement, asking for process improvement, asking for a cost reduction? Or that, what is the primary factor? Okay, and I can tell you there's only one of that. So read through it carefully. And then figure out which one is the primary, and then we'll talk through it. Okay? So it's 11:14. I'll give you 6 minutes to read through 11:20. Read through it, and then we will talk about it. What is this problem is trying to solve it? Okay? Still reading, you need more time? You guess good?
Yes.
Okay,
Are we allowed to write them?
yeah, that's your copy. You can write it on there. All right. So. This is problem, right? And. So how many of you are thinking the business problem is focusing for process improvement?
I'm actually looking at solar.
So let's go around, right? Let's say solar. Out of the five, which one do you think it is the biggest reason why they want to build a software?
The process, I'm actually looking at the process improvements and also the reduced costs.
But what is the primary one? When you read it, what was the thing that came out that what exactly they want to do?
Oh, not even the reduced cost.
You think it's a process improvement?
For me, I
Either
think
process improvement or market share. Just like you explained.
So
market
if I
share.
say it's solar, you have only one choice to
I
pick,
know.
which one you will pick?
Let me go with the process improvement.
Okay, so you're saying process improvement. Okay, what about you, Pooja?
there is, okay, I feel it is productivity.
Okay, so you think it's a productivity. What about you?
Market share and process improvement.
So you think it's, no, but which one? If I
Oh,
were to
which
pick one,
Process improvement.
okay, so two of you do process improvement, one is productivity improvement. What about you online?
Processor improvement.
Okay. So three of you think is a process improvement. Okay, so let's go look into this. Tell me here. Which one which statements here made you think it's a process improvement?
Because it said, currently there is not a single commercial product exists. That is.
But that's not process.
Mhm.
You say this process improvement, why it's a process?
Oh. Oh, that's not process.
There is no process that even exists because they don't even have the product. That's my thinking. I could be wrong.
So,
No, sorry.
go ahead.
The process improvement is, customer will be able to come into shop for auto repair as needed. And, dealers or shop employee will go to the, they'll be able to go to the website.
So think about it, right? When you think about process improvement, you're making some changes to existing process and making it better. That is process improvement. So what process you are making, you think it's making? a change? Is the process of getting the repair, it's getting better for them?
Well,
Yes.
it says here that a new system will be developed.
Right, but. So you tell me like which process it's improving? Is it the process of? Getting the money to fix the car, or is it the process of fixing the car? Overall end to end,
Fixing the car.
fixing the car, okay, what about you say the productivity improvement, what productivity is improving?
Um. That allows tracking dealer financing for auto repairs. That sentence, that whole sentence,
The first one,
yes.
so you think it's this thing,
Mhm.
right? Or is it this thing at the top?
The second,
Second sentence, so
Mhm.
it's. This sentence,
yes.
right? This one,
Mhm.
so. When you read it, what is the what is the actual business model that you're thinking they're trying to do? What is the actual business? Right, so think of what they're trying to do. If you go. To a car servicing shop,
Mhm.
right, you let's say, hey, I have so-and-so problem in my car, it needs to be fixed. Right? You go in, they say, hey, it's gonna cost you $5,000 to fix it. That's it. He says, I don't have $5,000. I need to fix the car. If you're buying a new car, right, you will get the loan from the bank. But if you go to fix the car. You have to come up with the money yourself. Right? What they're trying to solve the business is, okay, if you don't have a money. What if we give you a loan
Mhm.
to fix your car? So you're able to fix the car, get the loan, you'll pay it, instead of paying all up front, you will pay it over in installments. Right? So it's a win-win situation, because if I don't have a money and I said, I can't fix the car. And you walk it, dealer doesn't get any money, right? Because the car is not fixed, so they don't make any profit.
Mhm.
But if I have a loan, dealer gets it, they fix the car, they make the money. The person who's giving you a loan, they're charging you interest, so they make the money. And then you as a user, or the car owner, get your car fixed, so you're able to use the car also. Right, so that's what their business model is. I'll give you a loan to fix your car. Okay, so that's the model. Now, you say that they're doing process improvement of fixing the car. Why do you think it's a process improvement? Is it fixing car any faster? No, right? It's still gonna take me, if I need to fix that car, it's gonna take 6 hours, it's still gonna take 6 hours. So it doesn't improve the car fixing process.
It's the process of getting the loan.
It's a process of getting the loan. Is there a process today? There's none, right? They're billing, so you can't improve something that doesn't exist. Right? And you said the productivity improvement. What productivity is improved?
Like making it easier for the customer to track.
No, so think about it. Productivity is, I'm helping somebody to do their job more effectively.
Oh, okay.
That's productivity, right? So. Look in a book search example, right?
Mhm.
They were taking 8 hours.
Mhm.
I'm taking them to be more productive, so instead of doing only one customer a day, they're doing 4 customers a day. So they're more productive, instead of one, they're serving a 4 customers,
Mhm.
right? That's productivity. So what productivity is improving? And whose productivity is improving?
the companies,
Which one?
our flown.
But I don't have. I can't make it anything faster. I don't have an employee. So how is it improving my productivity?
Then it's improving the customer.
It's not even customer, right?
Or the
Customer is
dealer?
Getting the loan. So think of this way, right?
Uh-huh.
So this is where you need to think around it. Okay, the key statement is. There is not a single commercial product that allows them to do that today,
Correct.
right? So if there is no product, what is the market share? Zero.
Mhm.
I'm building a new product,
Mhm.
and when I build a new product, it's gonna help me do what? Go from a zero to some more than zero.
Mhm.
So it's improving my market share.
Yes.
That is what's driving me. Look, there's nobody in that market, there's no product.
Mhm.
I'm building a product to serve that need. Right?
Mhm.
And think of this way, right? What is the market share here? Who is paying for it? Is dealer paying for this system? No.
Mhm.
Is the loan provider paying for this system?
No.
No. Is the customer who is trying to come to get their car fixed, are they paying for this system? No. Our loan is paying for the system. And the way they say it's, I will build a system. So think around it, they are like it's becoming a brokerage, right? They're connecting the dealers to the lenders. To say, hey. If you go to get your car fixed and say, I don't have money, they said, you know what, wait. Maybe we can get you a loan to get it fixed,
Mhm.
right? And then they will work you to get the loan. And the ARF loan is gonna charge you a brokerage fee. To say it's, hey, I have all these lenders and all these dealers, so as a dealer. You see which lender is willing to give you a loan for that customer so that they can get their car fixed and you can make a money. Right? So our loan is a brokerage firm who's paying for building the software. So that they can do that,
Okay.
right?
Mhm.
So, and there's nobody exists today, right? So there's no market share.
Mhm.
So they said, we don't have market share, but we know there's that, if we build a product. Now people will use the products and we'll get market share more than a 0%. Okay, so are you still thinking? Tell me what's in your mind, what questions you have?
No, I'm still good. I was actually looking at also the cycle time improvements
Cycle time improvement for what though, that's the question.
to be able to, when you said, I mean, when they said things that will be done. Like a new system will be developed. as a
Right,
commercial
but
product.
think of it, what is the cycle time? Cycle time is not about getting the loan.
Yeah.
I'm not improving, right? I don't even have how long it will take it.
Mhm.
Also, I'm not improving the cycle time to fix the car. Because it's gonna still take the same amount of time. Whether I have a loan or not, to fix the car, right?
What about the last sentence? It says loan approval time by lenders from several days to within a week.
Well, that is their goal, but I don't know what is the time today.
Ah,
It says 7 days, right?
uh-huh.
So I don't know what is my baseline
Okay, okay.
in order to
Ah.
improve, right?
Mhm.
In order to improve my cycle time, I need to know what is my current time in order to improve.
Okay.
But since there is no product exists, I don't even have a time. for
That's
that,
true, yeah.
Right? Does it make sense?
Yeah, that makes sense.
Of how you go about analyzing it, it says, what is the business problem, right? So when somebody gives you a business problem, right? Think of this way, and this is where. The quality assurance's value comes into. All of you read the same problem statement.
Mhm.
You interpreted it differently. You said it was cycle time, you said it's productivity. Right, then you said, no, it's probably not there, it's a process improvement. Right, it's exact same statements that we all are reading.
Mhm.
We are reading it differently, right? It's a job of quality assurance person. is to make sure you understand what your business users want and why they're wanting. So that when you're building a test scenarios or quality assurance, you're making it sure that everything is in the context of why customer is doing this and what they want.
Okay,
That's why it's important to read the requirements and understand the context.
so which one is it?
It's a market share improvement,
Need to improve.
because there's no product, right? And I'm increasing the product, I'm getting it more than 0%. Alright. So I know this is harder to read. So I'm gonna actually. Gonna do this.
Okay.
So. Remember we talked about the planning phase in the SDLC?
Mhm.
Right? So how is the decision is made in a company in order to build it, whether they're going to build a software or not? Okay? So every company have this called something as a project approval board. Or some sort of a steering committee, which makes a decision whether they're gonna make an investment on certain projects or not. And the way they start with it is they ask you to say, what exactly is the project that you're trying to do it? How much it's gonna cost? How long it's gonna take it? And then what is the benefit at the end of that? Okay. It's the same standard process, right? What do you want? When you want? How much it's gonna cost? And how do you know it's beneficial or not? Okay, so let's say if I'm trying to like pitch a project, right? So you just read the R flow, right? Let's take it for example. If I'm trying to like let's go to my funding team to say, hey, I want to build a project for R flow, right? I want to build that product. The first question is going to be is, great. Let's talk about how much it's going to cost, how long it's going to take. And then once you're done with it, how long it will take it to make the money or profit. So let's say they say it's, hey, it's gonna take us $2 million to build it. It's gonna take us 12 months to build it. Okay, and so that's great, so we can give you $2 million for 12 months. But then how long it takes it for it to be profitable? It's gonna take us 3 years to make the profit of $2 million to cover the expenses that you've done. Right. So they're gonna look at it and says, okay, is it worth it? They said, what if I put the same $2 million somewhere else? And it's gonna make me more money than what you're projecting. If so, why would I fund you? Why would I not put my money there? Right, so that's the question that I asked. What is the benefit? Why would I invest it? But if I say, hey, it's gonna take me $2 million, it's gonna take me 4 months to build it. But it's gonna generate $10 million revenue in the first year. Then they look at it quickly, right? It's $2 million a year spending it. But I'm covering 4 times, I'm generating 4 times return that within a year. It's a good investment, right? No matter where you put it, it's not gonna get your 4-fold money in a year. So they said, yeah, it's good, let's go move with the project. Right? Or they can come and just say it and say, hey, you know what, you came up with $10 million. But your number doesn't make sense. Can you go and retune it and say, also they said 2 million is too much money. if I give you $1 million, can you tell me what you can do it and how much money it will generate? Right, so in those cases, then they will go back and do them, right? So the way the process starts at, you define the project, you do the cost, time, and the beneficial timeline estimate, right? And then you present it to the team, and the team looks at it and says, yeah, it makes sense. And then based on that return on investment criteria, right? Most of the company have criteria like it's, hey, if I give you money, it needs to return it within the 3 years or within the 2 years, right? There's always criteria. And every company will have different criteria, but they will have some criteria. Based on that criteria, they make a decision. Is it a good investment? Yes, then they will approve the project. If it is not good investment, they will say, yeah, it's a good idea, but it's not financially viable product. So we're not going to invest the money in it. Or they can say, it seems to be a good idea, but we need a little bit more information. We need to change some numbers. We need to change certain timelines and cost factor that we can give you. Why don't you do it? Another analysis, go back and then come back to us to do that. And then that's when they make a decision based on. This is what happens in the planning phase. Now, as a quality assurance person, you don't do much other than providing information. Hey, how much it's gonna help you to cost it? If I have to test the solution, how long will it take? But you don't do anything other than that. Okay, so that's essentially, it's the process that they use at the planning phase. Okay. What is the next phase after the planning in the SDLC? Do you recall? After planning, I want to build a house. What is my next step?
Analyze.
What kind of house you want to build it?
Design.
No, it's requirements.
Requirements.
You want to build a house, what kind of house you want to build it? Is it an apartment? Is it a standalone house? Is it a 3-floor, 4 floors, is it multi-story? What exactly you want, right? Same thing, you did the workflow, right? You said, this is the project, here's the money that you wanted. Okay, you got the money. What is your next step? To understand what is the detailed requirements, right? So that's where the requirement analysis comes into play. Okay.
Will we have this memorized by the end of the,
What, the SDLC?
yeah, the cycle?
Yeah, once you start practicing, you know the order in which you need it, right?
Mhm.
You don't have to memorize it. Think about it, like I gave you the example, right?
Mhm.
If you need to build something, what do you need first? You need to understand what are you gonna build it?
Yeah. Do we?
What are the capabilities that you wanna build it?
Mhm.
How are you gonna build it, right? Think about it, right? You see the kids playing the Lego all the time, right?
Mhm.
What is the first thing they say? Hey, I want to build a garden out of the Legos.
Mhm.
Well, why you want to build a garden, right? Is there a value? Yeah, we can just build a whole city type of thing. Then you go and ask it, okay, what kind of garden you want to build?
Mhm.
Is it a small park for the people to play? Or is it a big garden where there are a whole bunch of other activities people have been doing,
Mhm.
right? So that's a requirement. Then you say, okay, now that you have a requirement, it's a design, can you lay it out how you're gonna build it?
Yeah.
That's your design.
Mhm.
Then you start building it. And when you build it, right, it says, does this component fits here? Does it fit here?
Mhm.
Then you test it and says, are you happy with the garden? Yes. Okay, do you want to build anything else?
Mhm.
Same thing with this,
Okay.
right? You're building software. What exactly are you trying to do with it? And that, right? So requirements is nothing but a capability that you need to build in system that is gonna help you to fulfill the purpose.
Mhm.
So in our form, when we talked about, right? The capability you wanna build it is to connect the dealer and lender, right?
Mhm.
That's one of the capability to do that. Now, when you start talking requirements, right, people can write it in 2 different ways. Right? If you write it for the say, focus on what exactly the customer wants. A lot of times people will say it's a requirements definition document. What do you want? Right, but you can also write the requirement from a point of view that what does it take it to build it, right? So for a programmer's point of view, a lot of times you will hear a word called requirement specification document. Okay. Let's take an example. We talked about the house building, right? Let's say if I want to say, hey, I want a 2-story house with 3 bedrooms. That's a requirement definition, right? What do you want? It's from a customer's point of view. They want a 2-story house and they wanted so many bedrooms. But when you're looking for a constructor, for the guy who's constructing, right? They're gonna look at differently. How tall you want? I want 17 feet tall. The first floor needs to be 9 feet and the second floor needs to be 8 feet. Okay. I want it like 50 feet wide and 30 feet deep. That's a specification you're giving it to the constructor, that this is what I want. It's exact same requirements, right? One is from a customer's viewpoint of view. Right, as a customer, I don't care whether it's 8 feet and 9 feet, right? You measure it, you figure it out. I want it sufficiently tall enough. So that it feels like it's kind of open in there. Right? You see that two difference? A lot of times you see a requirements document which is a blend of both of those things. Okay. Then from a computer world, when you say it's a requirement, right? What do you need? Think about if I'm using a calculator, right? Nothing but a computer, right? And say, I want to add 2 plus 2. What do you need? You need, what is your input? 2 plus operator and another 2. Right? What is the output? If I add a 2 plus 2, that'll show me 4. That's output, right? What is the input? What is the expected output? Okay, what is the processing will happen in between? Well, it should add the 2 numbers. Right, I'm going to give you 2 numbers to input. It needs to add both of them, and that should be output, right? So every requirement is going to have something. What is the input? What is the business logic or rules that you need to apply? And what is the expected output? And then it also defines in some cases, what if there is an error? How are you going to handle that? Okay, so if I give you only one input and says perform that calculation, what should be the output? It should give you a message that, hey, you need at least 2 numbers for you to do add. So your functional requirement will always talk about what is input, output, and what is the processing errors. Then the second set of requirements is going to be non-functional requirements, which is often going to talk about what is the operating characteristics of your system. Right, this talks about how would I access it? Can I access it from anywhere? Or do I need to be in the office in order to access it? Okay. Second thing could be is, how would I access it? Can I access it through the user interface? Does it need to be a touch screen? Does it need to be a typing? What will be the type of inputs? Okay. What kind of data? What are the human factor? What is the skills needed for somebody to operate this application? Calculator, you can have it, small kids do that, right? Versus if you're doing this math computation and image processing, well, they need a little bit different skills than just the simple basic skills. That means I need to train them. Right, so what are my training requirements? What are my documentation requirements, right? So user manual, right? So you give a product, you give it with the user manual. If you want to perform this function, this is what you need to do at time. You will also have some security requirements. Right? So if I'm sending it credit card information, I don't want to send it in a plain text. I want it to be encrypted, right? So people cannot just essentially lift that sensitive information and misuse it for some other purpose. Okay. What is the quality aspects of the applications? How long it should be up? Right? So if you're trying to do a 911 system, right? Which is people's life and death is there, it needs to be up 24/7, it can't go down, right? Versus if I'm doing an ARP loan, which is like it's giving you a lender, right, loans and that. What are the chances people gonna be just walking it up to the car dealership only during the service hours, right? To fix the car, so they're gonna provide me the loan information only during that time. So I don't need 24/7 system. I can do it 7 in the morning till 7 in the night. When the shop closes, there's no more application for me. So all of those things are a non-functional requirements. Okay. Now, when you look at the requirements, you need to think it a little bit differently as a quality assurance person. Okay. The first thing you need to look at is the requirement correct? So does it belong into the problem space that you're trying to solve? Second thing you need to think about is it complete? Do I have enough information? For that, right? So if I just say, hey, you should be able to connect the lender and the dealer. Is that complete? Probably not, right? You need to understand is what is criteria I'm gonna use it to connect them. Give me that criteria, give me those specifications. So that I can understand complete. The other aspects you need to think about is it consistent? So within a document, you said, hey, if it is this, you do it this way versus if you do it this way. Now, there are multiple ways to do it. But are they all consistent? So if I'm using a calculator, right, I can say it's 2 + 2. And the next time I can say, whatever the existing number added 2 to it. Should I get the consistent answer? What it should do it? Should it be edited? So every time somebody gives you a requirement as a quality assurance person, first thing it should be in your mind is the 3 C's. Is it correct, consistent, or complete? Once it's done, then you should think about it as, can I test it? And when you ask a question, can I test it, if I do this, will it tell me? Does the system behave as expected, yes or no? So I should get a quick binary answer. If I test it, did it pass or not? Simple, yes or no? If I'm not able to clearly say it's yes or no, then the requirement is not precise. I needed a little bit more information in order to say yes or no. Okay? So that needs to be characteristics of any requirements that they give you. Let's take an example, right? If I say it's, one of my requirement is, it needs to have a master bedroom of 15 feet by 30 feet. If I'm building a house, is the requirement belongs in that? Yeah, because I'm gonna have master bedroom, right? So the requirement seems to be in that context. No. Is it complete? Is it sufficient for me to just say its master bedroom should be 15 by 30? Probably not, right? It says, okay, it's 15 by 30. But in what, should it be on the first floor? Should it be on the second floor? Where it should be? Right? So in order for me to complete, it's that, and this says, oh, and it should be in the same dimension as what is the code specifies. Right? Now I need to look at it as what is the code? It's an external document. Do I have a reference to that? What does code specify for the county? If I don't have that information, it's incomplete, right? Needs to say, where would I find the county code specification in making sure is it consistent with that one? Right, so that's again completeness or not. It's consistent. If I have a drawing or if I have a requirement that says, hey, my master bedroom should be the biggest in the house, but if there is another thing which is bigger, but then I'm saying it's 15 by 30. It's not consistent, right? What do you want? You want to be 15 by 30 or you want the biggest? And if it's the biggest, what should be the dimension? Right, so that's where its consistency and completeness comes into it. Okay, and then it's verifiable, when I build it. Can I measure it? From an edge to edge and say, is it properly or not? And if I can't say yes. Then that means I need some additional information. If I can say yes, then it's good enough, and I go through. Okay. Now, how do you collect those requirements? Like, so typically, as a quality assurance, you're a part of it, but you're not collecting it. It's your business analyst or product analyst, which are collecting those requirements. And typically they do through meeting with the expected customers or meeting with the expected stakeholders. This is, what do you want in this product? Okay, how long it took? A lot of times they do it by understanding it, what does customer want, what is the problem they're trying to solve. Sometimes they also identify looking into who are the stakeholder that I need to talk to get that information. Then they also talk about essentially interviewing with the customers. And says, how would you do this, right? So in fact, like it's in a R form, right? They will probably talk to the dealer and says, okay, how would you capture the information to understand what the loan is? And how would you send it to the lender? You go to talk to the lender and says, okay, if you have to give the loan, what information you need in order to make a decision, whether you can give the loan or not. Right? So you go through that interview process, capture all of that, and then essentially that's how you build the requirements. That this is what system needs to do.
Is this the acceptance phase?
This is still requirement.
Still
based. You're not only accepting. You just say, what should be behavior of the system collecting it. Same thing when you talk about a house, right? What should the house look like? You're just collecting the requirements, you're not accepting. Acceptance is once the house is built, is it built according to your specification? And that is acceptance phase.
Okay.
Now you can identify acceptance criteria at this phase. What do you think is system should look at it? When would you accept it? Like when you say, oh, my house is built, this, it's passed through all the inspection. That is what I'm defining as my criteria. When would I pay for it? Or why would I pay for it, right? That's an acceptance criteria. So what you're gonna look into it is through all those interviews, right? Whether it's for a small phase or for an entire waterfall, they will create a requirements document. That gives you an understanding of what you need to build it. What do you need to design it for, right? And those requirements document contains a whole bunch of additional information. Okay. And what are you gonna look into it? This is where your folder comes in. If I may borrow, to show your folder. Okay. Remember I said there are multiple tabs. The first tab is all your PowerPoint. Second tab is exercise, but the third tab is the project document. So this is what we're gonna do. We're gonna use our own project for all of our project work throughout the course. And then this is the document. So what I want you to do is this one has two documents. One is called requirements document. Another one is a design document. Right? So the third tab that all of you have it has those two documents. That's what I want you to read it. Okay? And I'll tell you in a moment because we're gonna pause here for today. But before that, I want to give you expectation of what you should be doing between now and Thursday and what we will do on Thursday. Okay, so if you go into it and for online, the all project document, if you scroll it in there, you're gonna find a requirements document, which calls requirement specification document, which is starting at page 7. So in your case, it's the start of the third tab. It should see it like this. Are you able to see it? The exact same thing? Okay. So if you go, it's about like 27-page document. Okay. So I want you to read it because it tells you what the system you need to build it, of all the requirements. And then once you go through it, you're gonna run into a second document. And it's called a system design document. Okay. Are you able to find the system design document? It's in the same tab. That. And if you're looking online, it is page 45 onwards. Okay. And then that is a required design document. So what I'm expecting all of you to read through this two documents, which goes all the way to page 72. So for online, it's page 7 to 72, which is about 66-page document across the two. So I want you to read it. And now, as you read through it, I want you to think around this 3C and the D condition. Do you understand that requirement? Do you feel it belongs there? Do you feel you have enough information to test it? That particular requirement. Okay? So it gives you the context of what is the project, what they're trying to build it. And your job as a quality assurance is to make sure, is it consistent? Is it complete? And if somebody builds it, can you figure it out how you will be able to test it? And get an answer, simple yes or no. Okay? Any question? So for you, it will be the,
Everything between this is all you need to read, between this and this. Okay, so after this is the third thing. So read this thing and apply that.
so,
It's from here. This entire. All this is three. Okay, so this is the first. This is the design. This is the requirements document, this is design document.
okay? So read it. Here are a couple of things I'll tell you upfront. The first time you read it, not everything will make sense. Some things will make sense, some things may not make sense. So you're probably gonna read it again. You will probably read it 1 or 2 times more to get the whole big picture understanding. And then as you read it, you look it through it and say, is there things which is inconsistent between the places within the requirements document or within the requirements document and design document, and flag those things. Okay? So have an understanding. What we will do it on Thursday is we will go through those documents with you. But we will, instead of going line by line, we're gonna ask you, okay, you read through it? Tell us what questions we have. So we'll address the question section by section and say, okay, you didn't understand that, let's talk through it. That's what we will be doing it on Thursday. Okay. Now, how will send it out information for you? Yeah, when you started, what is the Zoom number and everything?
I
Thursday?
already did.
You already did that?
Yeah.
So typically, we will start at 6:30. We'll go for about 2 hours.
Where did you send this to the email?
Yeah,
Email.
email. Yeah, are you, is everybody getting my emails?
Yes.
So you got it today? Yeah, I sent it today, okay? I think the email that you sent me via text, that's the same email. So let me know if you are not getting, because we will send out all
All of them recording, right? So
everything via email, so.
we'll pause.
I didn't get it.
Nothing, you didn't get
I
anything
got
today?
I got the previous one.
Oh, okay, yeah, that's fine.